All right, now for us to obtain the endpoint of this year's titration, theoretically, we need to first of all look at the molarity of the stock solution of hydrochloric acid, which is one of the specimens that we are working with. So we're working with hydrochloric acid, so we need to first of all know the concentration of the stock solution. Now remember that hydrochloric acid has about 30 something percentage purity. So the molarity is calculated using the percentage purity of the stock solution. And I might not have all the time to take you through the calculation, how we arrived at this value I want to state now. So the molarity of the stock solution of hydrochloric acid, HCl, is 11.4 molar. And that is what we are going to be using in this theoretical verification of endpoint. Okay? Then in the question, you were asked to measure 8.6 centimeter cube of the stock solution and dissolve it in 1000 centimeter cube of the solution. 8.6 centimeter cube of the stock solution is to be dissolved in 1000 cm cube of 1 liter of the solution. Now, with these values, we can obtain the desired or the expected concentration of solution A, which we are going to use in the volumetric analysis. So using the dilution equation is C1V1 equals C2V2. So, okay, when you multiply 11.4 by 8.6 and divide by 1000, that will give you 0.098 mole per dm cube. So we have obtained the final concentration of solution A in 1000 cm cube of the solution. So this is your Ca. That's your Ca. Now, let us move over to solution B. Now in solution B, you are provided with a compound known as sodium hydrogen triisocarbonate 4. So this compound is going to serve as the base in the volumetric analysis. Okay, so the molar mass of this salt is 84 grams per mole, and you're asked to measure 8.0 grams of this salt and dissolve it in 1000 cm cube of the solution. So the first thing I need to do is to find the amount of the salt that was dissolved in 1000 cm cube of the solution, and that's by dividing the given mass over the molar mass. So when you do that, you'll be getting 0.095 mole per dm cube. So that is the concentration of the base or solution B. So we have gotten our Cb. So our Cb is 0.095 moles per dm cube. So the next thing is for us now to apply the titration equation. The titration equation states that CAVA over CBVB is equal to NA over what? NB. So this NA over NB is the number of moles of acid that reacted and the number of moles of base that reacted, which can be obtained from the equation of the reaction. So the equation of the reaction involving hydrochloric acid and sodium triisocarbonate 4 is giving us this. So when this reacts with this, it will give you a salt, that's sodium chloride plus carbon 4 oxide plus water. So the equation is balanced. If you check very well, it is already balanced. Okay, so that means the number of moles of acid that reacted, which is the coefficient of HCl here, is 1. That of the base is also 1. So when we substitute in the titration equation, so we have Ca to be 0.098. Then Va is the expected volume of the acid that will give us the endpoint. Okay, then divided by Cb, which is the concentration of the base, we got 0.095. 9 times Vb. Vb is the volume of the pipette you used. which is usually 25 centimeter cube by capacity. Okay, you equate that to number of moles of acid to that of base that reacted, which is given as 1/1. So when you cross multiply to make VA the subject of the formula, then VA here will be equal to 0.095 times 25 divided by 0.098. So, and that will give us what? 24.2 centimeter cube. All right, so now we have arrived at the ideal value for this year's volumetric analysis or titration, 24.20. So this is called the ideal value. It doesn't mean that it is what you're going to get when you carry out the practicals. Your value might be a little bit lower or a little bit higher above what we have here. Okay, so this serves as a guide to you as a teacher, to you as a student. All right, so if this is the first time you're watching me live here on this channel, please do not leave without hitting the subscribe button. Please, I beg you, do that to encourage your guy, okay, to encourage your friend on this channel. Hit the subscribe button for us to keep doing the good work, okay? Then if you are a returning subscriber, please do well to like, share our videos, okay? Like our videos, share our videos. Now, in a couple of days, I will be posting another video on salt analysis. I promise it will not take long. I said couple of days. No, it doesn't mean that it will take like 3 days. Let me say between today and tomorrow, should be able to get my post on salt analysis. They will look at the expected questions or questions to expect in this year's salt analysis. So thanks for watching. God bless you.